All right, so for question 44, who wants to toss in how much zinc and how much HCl they have in the reaction and your temperature change? All right, so we've got 0.103 grams of zinc, and it combines with 58.6 milliliters of HCl, and that's aqueous HCl, so it's mostly water, right? And the temperature change goes from 23.1 degrees Celsius to up to 24.9 degrees Celsius. Yeah, so this is actually a chemical reaction, but the reaction happens in water, and they tell us a few important things, right? They tell us that they tell us the solution pretty much behaves like water, like it has the density of water, has the heat capacity of water. So we know the heat capacity is going to be 4.184. And because the density of water, right, is 1 gram per milliliter, we can basically say, okay, I've got 58.6 grams of water. So we want to find the mass of water. We know the heat capacity of water and the change in temperature. We can use that to find the energy that the water absorbed, and then we can use that to find the energy that was lost when zinc reacted. So we'll just plug in, and maybe I should say this is for the HCl solution so that we don't get confused, right? The mass, 58.6 grams. Again, your mass might be different, but the steps are going to be the same, right? Our specific heat, 4.184 joules, grams, degrees Celsius. And our temperature change, right, for this one is 1.8 degrees Celsius. So multiply those all together, and 58.6 times 4.184 times 1.8, right? I get 441.3 joules of energy. Because this is an aqueous solution of HCl, and they tell us in the bottom sentence that basically assume this has the properties of water, because it's HCl in water, right? It's an aqueous solution, but it's mostly water, right? It's 99% water, right? All right, so we know that the water, right, absorbed 441.3 joules of energy. So again, right, third time tonight we've seen this. It's because the reaction, right, when zinc reacts with the HCl, it's going to lose 441.3 joules of energy. Now I'm going to do the same thing we did before. We're going to just take zinc and we're going to turn it into moles, right? So because we're looking for the energy for this reaction in kilojoules per mole. So I've got 0.103 grams of zinc, and MK is going to tell me that zinc is like 64 grams per mole or something like that. Oh, MK's leaving me hanging here. Oh, 65. All right. Thank you. 65. It's close. 65.38 grams per 1 mole. All right. So 0.103 divided by 65.38, and we get 1.575 times 10 to the minus 3 moles of zinc. So we're looking for energy in kilojoules per mole. So we'll do one step first, right? I know for 1,000 joules, 1 kilojoule. So negative 0.4413 kilojoules. And now I'll divide that by my moles of zinc. So divide that by 1.575, 10 to the minus 3 moles. And I'll turn that into energy. So our kilojoules per mole. So 0.4413 divided by that. And I get like minus 280 kilojoules per mole. So minus 2.80 e to the 2 kilojoules per mole for question 44. Here, we needed the mass, we needed to find it as energy per mole because that's what they were asking for in the question, right? They asked for what's the heat of this reaction in kilojoules per mole. So that was kind of different than the previous question where they just wanted to know the heat. They didn't really care about per mole, the heat. They just wanted to know the overall heat that was released. So that's question 44.